Hello everyone and welcome to this next session of the CCNA online training program. Now today what we are going to really do is continue with where we left off in the previous session that was related to IP addressing, and we talked about things such as binary numbers, binary to decimal conversion. We also discussed about decimal to binary conversion. Okay, we then talked about IP address in general with regards to the various classes of IP address. Okay, we also discussed about the subnet mask, the default subnet mask for each of the classes of IP address, that is class A, B, C, D, and E. Okay, so basically we ended our session in the previous one based on that particular notation, and ultimately we talked about the various different methods of notifying or specifying the subnet mask, that is the decimal notation and the CIDR notation. Okay, so these are the two major things that we talked about before we ended the session previously. Okay, now today what we are going to really do is continue with the same thing. Okay, but now once you know about the subnet mask over here, okay, we were talking about the various classes of IP address, and I told you class A, the default subnet mask is 255.0.0.0. Class B, the default subnet mask is 255.255.0.0, and for class C, the default subnet mask is 255.255.255.0. Okay, that's the default subnet mask, but doesn't mean that every class A or every class B or class C address should have the subnet mask. Okay, these are the default values, but it can also be modified. Now, out of the three, out of the 5 classes that we have here, these 3 classes, that is class A, class B, and class C addresses are used commercially. Okay, class A, class B, and class C addresses are used commercially. Now, what I mean by commercially is on the networks, for computers or for devices, typically we make use of IP addresses within class A, class B, or class C. Okay, these are the classes that are used for assigning IP addresses to individual devices. Okay, but then we also have class D and class E. Okay, class D, when we talk about it, it's typically used for multicasting. Okay, class D is used for multicast IP addressing. Okay, like in the earlier sessions we had discussed about multicast communication, right? Multicast communication is one to a group. So if you want to have that kind of a communication, the IP address that is used is typically class D. Okay, and then we have class E, which is used for research purposes. Okay, that is typically reserved and used by the military, or typically it is used for research purposes. Okay, so these are the 5 classes of addresses that we can have. Okay, so out of the 5 classes, class A, B, and C are used commercially. We have class D that is used for multicast, and we have class E that is reserved for research purposes or research and military purposes. Are we clear about the various classes of the addresses now? Okay, so let's continue to the next portion. Okay, now in the next portion, what we are going to really talk about here is, okay, we are going to talk about a section wherein we'll be talking about given an IP address, that is once you are given an IP address and a subnet mask, how to determine the network address. Okay, that's what we are going to talk about, and then we are going to talk about another term known as broadcast address. Okay, so we are going to talk about 2 different things out here, but so the logic out here would be, let me just put it down. Given an IP address, okay, we are going to derive network address and host address. Okay, that's what we are going to derive. Also the broadcast address. Okay, that's the next thing that we are going to talk about. Okay, so once we are given an IP address, okay, along with the IP address we also need a subnet mask. So once we are given an IP address and a subnet mask, we are going to derive the network address host address as well as the broadcast address. Okay, so these are the things that we are going to discuss about right now. Okay, so let's go ahead and do that. So to discuss about that, okay, let's take the first example, and accordingly then we'll talk about how to derive it or how to calculate it. Okay, so the first example that I'm going to put across is 192.168.1.100. Okay, that's the IP address. Okay, and slash 24. Okay, now that's the subnet mask. Okay, so now the subnet mask that I've given in this particular example is the CIDR notation. Okay, can you tell me the decimal notation for this particular subnet mask? Yes, the decimal notation for the subnet mask. I have put up the CIDR notation. So can you give me the decimal notation for the subnet mask? That's absolutely right. Okay, so the decimal notation for the subnet mask in this example is going to be something like this. Okay, so I'm going to put up the IP address as it is. Okay, so it's going to be effectively represented as 192.168.1.100, and the subnet mask is going to be 255.255.255.0. Okay, so that's the question that is given to us. Now, based on this question, we are supposed to derive, okay, the network address, the host address, and the broadcast address. Okay, these are the three things that we are going to derive out here. Okay, so let's go ahead and do that. Now, when it comes to this particular IP address that is given in the question, can you tell me what class of an IP address this is? What is the class of IP address? Yeah, it is a class C address. That's absolutely correct. Okay, and it's using the default class C subnet mask as well. Okay, now let's talk about how to go about calculating the network address and the host address and the broadcast address. Okay, so let's first talk about network address. Now, to derive the network address, okay, there is a formula that we are supposed to follow. The formula that we are supposed to follow is IP address. Okay, so we are supposed to take in the IP address, okay, and we are supposed to take the subnet mask, but for taking in the subnet mask, we are supposed to make use of the AND logic. So what we are basically supposed to do is, we are supposed to apply AND between IP address and the subnet mask. So when we do an AND between the IP address and the subnet mask, we get the network address. Okay, so that's the formula that we are supposed to use. We are supposed to use the AND logic between the IP address and the subnet mask. Okay, so we are supposed to use a logical ANDing of the IP address and the subnet mask to derive the network address. Okay, now just to recollect the AND logic and the OR logic that we covered yesterday. Okay, I'll just take you directly to that section here. Okay, now these are the two logics that we talked about yesterday, and this is what we are focusing upon, this section here. Okay, so what you notice here, if both the values are 1, the resultant value is also 1. If both the values are 0, resultant value is also 0. But if one is 1 and the other one is 0, the resultant value is always 0. Okay, so that's the logic that you need to keep in mind. So bottom line is, anything you AND with 0, the resultant value is going to be 0. Anything you AND with 1, the resultant value is going to be the same. In the sense, if I add 0 with 1, okay, the resultant value is going to be 0. If I add 1 with 1, the resultant value is going to be 1. But anything you add with 0, that is 1 you add with 0, the resultant value is 0. 0 you add with 0, the resultant value is 0. Okay, so like I told you yesterday, I remembered it in the form of multiplication. Like if I multiply anything with 0, the value is 0. But if I multiply anything with 1, the value is the original value as it is, right? Okay, so that same logic will apply here as well. Like let me just show that to you. Now for calculating or carrying out this logical ANDing, we have to break down this entire decimal notation of the IP address as well as the subnet mask into binary. Okay, now that's what I need to do. I need to convert this entire thing into binary. But rather than getting into those complexities, one of the best ways or the simplest ways of doing it is, okay, just follow the same logic which I just discussed about the AND logic. Like I'll break down this entire thing in the form of spaces here. So 192, 168, 1 and 100. Okay, these are the 4 octets that we have. And as far as subnet mask is concerned, 255, 255, 255 and then 0. These are the 4 octets of the subnet mask. Okay, so this is what we have. Now saying that, what I'm supposed to basically do is I'm supposed to apply the AND logic. Okay, so talking about the AND logic. Okay, talking about the AND logic, typically what we are talking about is anything you AND with 0, the resultant value that you're going to get is going to be 0. Okay, so that's the logic that we have here. Okay, in fact, yeah. Okay, so let's talk about that. I mean, now here, if I talk about it, 255. When I talk about this decimal value, the binary equivalent of 255 is all the individual bits are ones. Do you agree to that? Okay, 255 means 8 bits are ones out here. Okay, all the 8 bits are ones, which means if I AND this 255 with 192, the resultant value that I'm supposed to get in the first octet is going to be 192. Do you understand that? Okay, because like I discussed about it just a little while ago, anything you AND with 1, the resultant value is going to be the same, right? So here we are considering 192 at one end, and at the other end we are considering all the individual bits as ones. Okay, so effectively the value is going to be the same, that is 192. Do you understand this? Okay. In fact, let me just show it to you out here itself. So I'll just take the example of 192 right now. 192, if I want to represent it in terms of binary, okay, it is going to be 128. That's the first. Then 64. Okay, 128 plus 64 is 192. So it's going to be 1100 0000. Do you understand? That's the binary value. Okay, that's the binary value for 192. Now similarly, if I talk about the binary value for 255, the binary value for 255 is going to be 11111111. Okay, so all the bits are ones. Do you understand this? Okay, so effectively now if I AND these two, okay, if I AND these two values, okay, take each bit one by one, like the first bit here and the first bit here. So 1 and 1 is going to be 1. Do you understand? Second bit now, 1 and 1 here, that is going to be again 1. Third bit, 0 and 1 is going to be 0. Fourth bit, again it's going to be 0 and 1, that's 0. 0 and 1, that's 0. 0 and 1 again, that's 0. 0 and 1, that's again 0. And the last bit is also 0 and 1, that's 0. Do you understand this? Okay, so the resultant value that you're getting here is the same as the original value if all the bits are 1. Do you understand that? Now do you get it? Okay, so that's how I derived this 192 here. Okay, so the logic is the same even for this first octet, second, third and fourth. Okay, everywhere it's going to remain the same. Now let's talk about the next octet, second octet. Now if I talk about it, second octet is 168. Now if I AND this binary equivalent of 168 with the binary equivalent of 255, the resultant value is going to be 168 again. Do you understand this? Okay. Now let's talk about the third octet. Now if I talk about the third octet is 1, and if I AND with 255, the resultant value is again going to be 1. Do you get that? The same logic like I talked about before. Now let's talk about the last octet. Now if I talk about the last octet, the subnet mask, the last octet is 0. 0 means all the bits are going to be zeros out here. Okay. But then before that, let's put up the equivalent of 100. Okay. Let's represent 100 in terms of binary. So 100 in terms of binary is going to be 0, 1, 1, okay, 0, 1, 0, 0, 0. Okay, that is what is 100. Do you agree? I mean, you can calculate it in the meanwhile, and then you can tell me whether I am right or wrong. Okay, in fact, I am wrong. Okay, it should be 100. Sorry about that. Yeah, you can check it up. Okay, and then you can come up with the value and you can compare with this. The binary value for 100. Okay, so that's the binary value for 100. Now if I put the binary value for 0, it's going to be 0, 0, 0, 0, 0, 0, 0, 0. That's all the 8 bits would be zeros. Okay, so effectively now if I talk about the ANDing between these two values, okay, let's go bit by bit. The first bit, if you look at it, 0 and 0 is going to be 0, 1 and 0 is going to be 0, 1 and 0 again is going to be 0. Then the fourth bit is going to be 0 and 0, that's 0, 0 and 0 again, that's 0, 1 and 0 is going to be 0, 0 and 0 is going to be 0, and 0 and 0 again is going to be 0. Okay, so bottom line is, the logic that I want you to understand here is, whenever we work with binary, okay, if all the bits in an octet is a 1, okay, anything you AND with that particular octet, you are going to get the same value back. Okay, that's the reason you find the first 3 octets you're ANDing it with all the 8 bits of 1. That means you get the resultant value as the same. But anything you AND with 0, the resultant value that you get is going to be 0. Okay, so in this case, the resultant last octet that you see is going to be 0. Do you understand that? Okay, so bottom line is, this value that you get, that is 192.168.1.0, this is going to be the network address. Do you understand this now? Okay, this is how you calculate the network address. Okay, so the network address is calculated by ANDing the IP address and the subnet mask. Okay, so when you AND the IP address and the subnet mask, the resultant value that you get is the network address. Okay, now let's talk about the next value, that is host address. Now to derive the host address, the formula is going to be host address is equal to IP address minus network address. Okay, so the host address is equal to IP address minus the network address. Okay, so according to this example, the host address would be then equal to the IP address that was given to us was 192.168.1.100. Okay, that's the IP address. Then we have to minus or subtract the network address. What is the network address? 192.168.1.0. Okay, so if I subtract each and every octet one by one, the resultant value that I'm going to get is going to be 0.0.0.100. You understand that? Okay, great. Okay, so this is going to be the host address. So if you now look, if you add the host address value, that is this one, plus the network address value, that is this one, you effectively get the IP address. That was the first formula that I gave you at the start of this particular topic. Do you understand that? Okay, so understand this. Whenever we talk about an IP address, it is an addition of network address and a host address. Okay, so that is what it is. Clear about that now? Okay. Understood how to derive the network address and the host address? Okay. So bottom line is, like the explanation that I gave you right at the start of this particular topic, I told you a network address is like a classroom, and a host address, okay, would be like a roll number of each and every child in the classroom. Okay. So out here what we have found is that is the network address. Okay, and this is the host address. You understand that? Okay. Now, one thing that you might have understood now here is, if you look at the network address here, okay, the leftmost portion of the bits, okay, there are some values to it, but the rightmost portion is all 0. Okay, now that is what is determined by the subnet mask. As you notice, the first 3 octates are all ones, the last octet is all 0. Do you understand that? Okay. Okay, if you look at the subnet mask, that is what determines what is the network address and the host address, right? So the network, the subnet mask tells you how many bits are used by the network address and how many bits are used by the host address. Okay, so if you look at the subnet mask again now, okay, the number of bits that are ones represent the network address, and the number of bits that are zeros represent the host address. Okay, again let me repeat. So number of bits that are 1 represent network address, and number of bits that are 0, okay, is nothing but host address. Do you understand that? Okay, any questions with regards to this one now? Okay, so let's go ahead now. Okay, so we have now derived the network address and the host address. Okay, what question do you have? I mean, which part have you not understood? What I was saying is, whenever we talk about the network address and the host address, okay, when you look at the subnet mask is going to tell you how many bits are being used by the network address and how many bits are being used by the host address. That is, the number of bits in the subnet mask that are ones, okay, the number of bits that are ones in the subnet mask represent the network address. So in our case, the first 24 bits are going to be the network address. Okay, and when it comes to the host address, okay, the last 8 bits are going to be the host address. Do you understand that? Totally is going to be 32 bits, out of which the first 24 bits are the network address and the last 8 bits are the host address, according to this example. Okay, great. Okay, so let's now continue. The third or the next value that we want to derive is the broadcast address. Okay, now whenever we talk about an IP address, that is an identifier that is assigned to each and every device, right? Okay, network address is an identifier for the network. Host address is the identifier for the individual host. Okay, I hope you are very much now clear with regards to each and every term: network address, IP address, and the host address. Are you clear about these three terms now? Okay, so then let's now discuss what is a broadcast address. Okay, let's now discuss this term, that is broadcast address. Broadcast address, when I talk about it, okay, it is the last address available within a network address. Okay, what is a broadcast address? It is the last address that is available within a network address. Okay, it is the last address available within a network address. So whenever we talk about network address, it will contain a lot of different addresses inside it, right? Okay, now all of them are IP addresses, but the last one out of that list is the broadcast address. Okay, but what is the purpose of this broadcast address? Let's talk about that. A broadcast address would be, okay, a value or an address in which when we send some traffic or send some data to this broadcast address, it's going to reach all the nodes belonging to that particular network. Okay, so when I send some data to a broadcast address, it is going to reach all the hosts belonging to that particular network. Okay, so a broadcast address, it is an address that is used to communicate with all the nodes on a network. Okay, so if I want to communicate with all the nodes on a network, I make use of a broadcast address. Do you understand that? Clear about this now? Okay, so let's talk about how to calculate the broadcast address. Okay, well, to calculate the broadcast address, okay, the simplest way to calculate the broadcast address would be to make all the host bits in a network address to be all ones. Okay, what you're supposed to do is you're supposed to look at the number of host bits and you calculate or convert all the host bits to 1. Okay, like in this example, what we have is the first 3 octets or the first 24 bits are network bits. Do you agree? Okay, in this example, the first 24 bits are network bits and the last 8 bits are host bits. Okay, that is what we just discussed about, right? So what you're supposed to do is you're supposed to keep the network address as it is. Okay, but when it comes to the host bits, you're supposed to convert this entire host bit to 1. Okay, so host bits by default in a network address, they are all 0, right? Like if you look at the network address here, the network address is 192.168.1.0 and this last octet here is the host bits, all zeros, right? You're supposed to convert these all zeros to ones. Okay, you're supposed to convert it to 1. That is what you're supposed to do to calculate the broadcast address. Okay, so bottom line is, if I talk about the broadcast address, I'm supposed to take the network address, that is 192.168.1. Now these are the network bits, right? These 3 octets. The last octet is the host bits, and the host bits by default are all zeros. Okay, that is the default bits that we have here according to the network address. But what you're supposed to do is you're supposed to convert all of this to 1. Okay, instead of zeros, you have to make them 1. That will give you the broadcast. Okay, so if I convert all of this to 1, it is going to be all ones. You understand? All the 8 bits are going to be 1 because the number of host bits that we have is 8. So we are converting all of them to 1. So if you do that, and now if I represent this, it is going to be 192.168.1. Now if all the 8 bits are 1, the decimal value for that is 255. So this is going to be the broadcast address. Do you understand that? Clear about this? Okay, so the simplest way to calculate the broadcast address is you have to convert all the host bits to 1. Okay, so that is what you're supposed to do. So effectively, given this IP address and the subnet mask, okay, you're supposed to calculate the network address by ANDing the IP address and the subnet mask. So the effective value that you get, it would be the network address. To calculate the host address, you have to subtract the network address from the IP address. That is where you get the host address, okay. And then to calculate the broadcast address, you are supposed to convert all the host bits to 1. When you do that, you get hold of the broadcast address. Are we clear about this? Okay, we are going to take one more example so that we understand it very clearly. Okay, but I hope you have understood the logic behind this. Okay, so that was example 1. Okay, let's get on to example number 2. Okay, so the second example that we have is 172.16.25.35/16. Okay, now this is what we have. Okay, this is what is given to us. Okay, so accordingly now, if I represent this IP address in the form of the decimal notation, okay, so it's going to be something like this. It's going to be 172.16.25.35 slash, and the subnet mask could be represented as 255.255.0.0. Do you understand this? Okay, just let me know if you have any doubts. Okay, I'm just going to go a bit faster here because I'm assuming that you've understood the previous example very nicely, and accordingly then I'm going to follow the same logic and I'm going to calculate it. Okay, so just interrupt me if you find any difficulty understanding it. Okay. Okay, so that would be the decimal representation. Now, to calculate the network address, we have to AND this IP address and the subnet mask. Okay, so the logic for that would be, if I'm ANDing anything with 1, okay, so if I'm ANDing anything with 1, the resultant value is going to be the same. But if I'm ANDing anything with 0, the resultant value is going to be 0. That's the logic that we are supposed to follow. You understand? Okay, so ideally what I'm supposed to do is break down everything into binary and then I'm supposed to calculate it. But I gave you a shortcut, right? I gave you a simpler method. What was that? You're just supposed to look at all the bits that are ones. So anything you AND with 1, the resultant value is going to be the same. That is the logic here. So if you notice here, these first 2 octates are all 1. So which means the first 2 octates are going to remain as it is. But the next 2 octates which you see are all zeros, which means the resultant value is also going to be 0. Do you understand that? Okay, so according to this example, if I AND the IP address and the subnet mask, I'm going to get 172.16 because the first 2 octates of the subnet mask are 255. So I'm going to get the same value, but the last 2 octates in the subnet mask is 0, which means the resultant value that I'm going to get is going to be 0.0. Do you understand this network address now? Any questions with regards to this one? Okay. Okay, so this is my network address. Now let's talk about the host address. So the host address, if I look at the formula, the host address is, you have to subtract the network address from the IP address. Okay, so what is our IP address? Our IP address is 172.16.25.35. That is our IP address. We have to subtract the network address, that is 172.16.0.0. Okay, so resultant value that we are going to get would be the host address, that is 0.0.25.35. Do you understand that? This is going to be our host address. Is it pretty straightforward? Simple enough to understand? Okay, great. Okay, so this is how you calculate the host address. Now let's talk about the broadcast address. Okay, now to calculate the broadcast address, we need to know how many bits are the host bits and how many bits are the network bits, right? That's what you're supposed to look at. So based on our previous example, can you tell me how many bits out here are the network bits and how many bits are the host bits? Try to guess it or try to work on it. Okay, you need to tell me how many bits are the network bits and how many bits out of these are the host bits. Yes, 16 network bits, that's absolutely correct. And how many host bits? That's correct. The remaining 16 would be the host bits. Okay, so it's pretty simple to understand that. I mean, you're just supposed to look at the subnet mask. Okay, you're not supposed to even look at the network address or host address or the IP address at all. You're just supposed to blindly look at the subnet mask, or in fact not even the decimal notation of the subnet mask. You're just supposed to look at the CIDR notation of the subnet mask, and what you notice out here is it says /16. So this 16 itself tells you the number of network bits, and the remaining would be the host bits. Do you understand that? Okay, so remember this, if at all you come across a decimal notation, then you're supposed to look at the number of bits that are 1, that is going to be the network bits, and the number of bits that are zeros, that are going to be the host bit. But if you have a CIDR notation, then in that case the value that is defined in the CIDR represents the number of network bits, and the remaining would be the number of host bits. Do you understand? So according to this example now, okay, since we have 16 network bits and 16 host bits, so then if I want to calculate the broadcast address, okay, the broadcast address is going to be, you have to convert all the host bits to all ones. Okay, so based on that, can you tell me what would be the broadcast address for this particular example? Try to solve it. Okay, what you're supposed to do is convert all the host bits to 1. That is what you're supposed to do. So based on that, can you tell me what would be the broadcast address in this example? That's perfectly correct. Okay, that is 172.16. That's the network address. So the network bits, we are not supposed to touch them at all. The host bits, we are supposed to convert everything to 255. So effectively, we are going to get the broadcast address as 172.16.255.255. Okay, so are you now feeling confident with regards to network address, host address, and broadcast address? Any questions or doubts that you have? Okay, great. Okay, so let's get on to example number 3. I'm going to give you one more example, but here, okay, you're supposed to solve this particular example on your own, and of course, I'll be here to guide you with regards to that. Okay, so let me give you the example. So example 3. Okay, I'm going to make it a bit tougher. Okay, but so that you are able to clearly understand, or you're supposed to, you're able to clearly grasp the concept. Okay, that's why I'm going to make it a bit complex. Okay, so the example that I'm giving you is 192.168.55. Let's say 33/28. Okay, that is what I'm putting up. And for this particular example, you're supposed to tell me the network address, the host address, and you're supposed to tell me the broadcast address. Okay, so calculate it and you're supposed to give me the response. Okay, give it a try. Okay, so what is the confusion that you're getting? Okay, okay, so let me start off, okay, and then we'll discuss about it. Okay, so what is the formula for calculating the network address? You're supposed to logically AND the IP address and the subnet mask. Okay, so well, like I told you before, it depends on your comfort level of how to go about it. But you know what you're first supposed to do is convert it to decimal notation so that it becomes easier to understand. Okay, so typically it's going to be 192.168.55.33 slash 255.255.255 dot. Now, what is the decimal notation of this subnet mask? Can you tell me that? It's going to be 240, not 140. Okay, because if you calculate it, it's coming out to 255.255.255.240. Okay, so that is how it's going to be. Because as I told you, whenever we talk about a subnet mask, the first 28 bits according to this one is all 1. You understand? Okay, so I think since you got this subnet mask itself wrong, that's why you're getting confused with the network address. Okay, now based on this, let's try to calculate the network address. Okay, now the logic remains the same. Anything you AND with 1, the resultant value is going to remain the same, whereas anything you AND with 0, the resultant value would be 0. Okay, that's the logic that we are supposed to follow. So based on that, now if I talk about the first 3 octates, okay, they are all going to be the same because the subnet mask first 3 octates are all 255. Okay, so effectively the first 3 octet at least is going to be 192.168.55. Okay, that much is fine, but now the last octet is going to be a tricky option, because we have not really learnt about it this way, right? Okay, but the logic, like I told you, you're supposed to use the binary value, and then accordingly you're supposed to perform a logical AND. So let's go ahead and do that. Okay, let's perform a logical AND out here. So to perform the logical AND of the last octet, let's first represent 33 in terms of binary. So if I represent 33 in terms of binary, it's going to be 0, 0, 1, 0, 0, 0, 0, 1. That is going to be 33. Do you understand? This is how I would represent 33. Okay, and then I'm going to make use of a logical AND here, and when it comes to 240, it is going to be represented as 1, 1, 1, 1, 0, 0, 0, 0. That is how it's going to be 240. Do you agree? Okay, so what I would recommend you to do is, try to do the conversion along with me. So the more you would practice, the faster you would be, and the more better you would be able to work on these kind of problems. Okay, because it's always a good idea that you practice these numbers a lot. I mean, we always think about why do we need to really think into or get into addition, subtraction, and all that. Well, the main thing is, like, the more you do it, the sharper you'll get, and the better you would be able to perform with regards to questions like related to IP addressing and all that. Okay, so that's why the more you practice, the better. Okay, so that's what you need to do. Okay, now let's come back to this one. So let's do an ANDing bit by bit. So if you look at that, okay, one thing you'll notice is if you look at these bits here, the first 4 bits are all 1. If the first 4 bits are all 1, naturally these first 4 bits are going to remain the same. Do you understand? Okay, so if the first 4 bits are all 1s, the resultant value is going to remain the same. So it's going to be effectively 0, 0, 1, 0. So the first 4 bits are going to remain the same, but the last 4 bits are all zeros, which means they are going to convert to all zeros. Do you understand? Okay, so I'm following the same logic. Anything you AND with 1, the resultant value is the same, whereas anything you AND with 0, resultant value is going to be 0. Do you get that now? Any questions with regards to this one? Okay, so based on this now, if I calculate the binary decimal value for this binary value, okay, it's going to be 32. So that becomes my network address. Do you understand how to go about doing this? Okay, so the logic is going to remain exactly the same. You are supposed to convert this entire number into binary, and then you're supposed to do a logical ANDing. Okay, but then why I gave you the simpler method is because if you try to convert everything into binary and try to do it, you'd be very slow. Okay, well, that's not a bad thing. I mean, you would start slow, and then the more you practice, the better. But then I'm giving you the simpler method so that at least for the octates which are fully all zeros or fully all ones, you would be able to do it quicker. You would be only need to do the calculation for the octates which are having these kind of values, like the thing that we saw with regards to the last octate here. In the last octate, all the bits are not ones or all the bits are not zeros. So that's the only portion where you need to really calculate, but everywhere else you can just leave it as it is. Do you understand that? Okay, so that is the network address. Now based on this, can you now calculate the host address? That's absolutely correct. Okay, so the host address is going to be 0.0.0.1. Okay, so remember, whenever we define the host address, do not think about it just as okay, just because we have zeros, so just put or ignore the zeros and then just put 1. Okay, you have to always represent the host address or the network address in the 32-bit format. Okay, so based on that, this is the host address that you're going to see. Do you understand? Okay, but sometimes in the case of network diagrams, when you refer to network diagrams, you would notice that instead of this 0.0.0.1, you can also see sometimes that is dot 1. This dot 1 represents that it is 0.0.0.1. Okay, that is the host address. Okay, now in the network diagram they put it this way just because there may be lack of space, or due to the complexity of the diagram it becomes a bit difficult for the lack of space. Okay, due to the lack of space. So that's where they might use these kind of notations, but ideally you're supposed to use the 32-bit format to represent the host address. Okay. Now based on that, can you tell me the broadcast address? No, okay, that's not a correct value. Okay, let's calculate now the broadcast address. Okay, let's take a look at that. So for calculating the broadcast address, what did I tell you? I told you that you're supposed to convert all the host bits into 1. Okay, that is what you're supposed to do. Now for that you need to first of all know how many network bits and how many host bits. Okay, that is what you need to know. So can you tell me how many bits according to this example are the network bits and how many bits are the host bits? How many network bits and how many host bits? That is what you're supposed to tell me now. No, it's not 24 network bits and 8 hosts. Okay, look at the example. According to the example, the CIDR notation for the subnet mask is /28. So according to that, we are talking about 28 network bits and 4 host bits. Okay, you're supposed to look at the subnet mask. The subnet mask is /28. /28 means 28 network bits and 4 host bits. Do you understand? Okay, because what you have mentioned of 24 network bits and 8 host bits, that is according to the default subnet mask. But since the subnet mask is already given to us, we cannot take the default subnet mask. Okay, according to this example, the subnet mask is /28, which means 28 network bits and 4 host bits. Do you understand it very clearly? Okay, so according to that now, okay, we are supposed to convert just the last 4 bits to 1. That is what we are supposed to do. Okay, so which means if I talk about the first octet or the first 3 octets, it's going to remain the same, that is 192.168.55. okay, and the last octet according to the network address is this way, so which means it is 0010. Okay, so the first 4 bits are going to remain the same as it is according to the network address, but the last 4 bits, instead of it being 0, it is supposed to be converted to all ones. So 1111, that is what is going to be. Okay, so effectively our broadcast address is going to be 192.168.55. Now you have to convert this binary into decimal now. Okay, so try to do that and give me the value. That's absolutely correct. Okay, it's going to be 47. Okay, so remember this. I mean, do not forget your concepts. Okay, if you remember your concepts, it's going to be absolutely easy. Okay, but the moment you miss out on the concept, then that's where you're going to go wrong. Okay, so remember that. So based on that, now let's take another example. Okay, the final example for this section, so that you are able to, like, grasp the topic. Okay, so let's go ahead and do that. So example 4, that's what we're going to work upon now. Okay, again the same thing. I mean, I'm going to ask you to do this particular example or solve this example and accordingly come up with the solution. Okay, so the question that I'm coming up with is 172.38.96.254. okay, /18. Okay, now that's the example that I've given you, and based on this, you're supposed to give me the three values. Okay, let me just put that up for you. So the three values that you're supposed to give me is, first of all, network address, then you're supposed to give me the host address, and you're supposed to give me the broadcast address. Okay, so I don't mind you taking time, but see to it that you try to solve it, properly. Okay, so according to you, the subnet is going to be 172.38.96.0. Okay, the network address is going to be this one. Well, I would say that is not right, or that is not correct. Okay, so let me just show that to you. Okay, the network address part. So for calculating the network address, again the same story. Okay, I think in your case, I think you're getting lost with regards to the subnet mask. That's where you're going wrong all the time. Okay, so let me just give you the subnet mask first. Okay, so according to this one, the decimal notation of the subnet mask is going to be 172.38.96.254. okay, /. Now 18 is what we have, so 255.255.192.0. that is what is going to be my subnet mask. Did you get the same subnet mask or did you get something different? come again? I didn't understand you. No, it's not going to be 255.255.0.0. You know, see, look at the logic here. What is the subnet mask given to us? Based on that, you would be able to calculate, because if you assume the default subnet mask, you're always going to go wrong. You're assuming the default subnet mask all the time, which is where you're going wrong all the time. So be sure to concentrate on the subnet mask which is given to you. Even in the exam, it's going to be the same story. You cannot assume the subnet mask. You have to look at the subnet mask that is given to you in the question. Okay, so according to the subnet mask that is given to you in the question, that is /18, how would you represent it in decimal format? What is it telling you? 18 bits in the subnet mask are 1. Okay, so if you put all the 18 bits as 1, this is what you're supposed to get. Okay. Sorry about that. Yeah. Okay, are you getting me? Why did I get this kind of a subnet mask? Do you understand how we derive this subnet mask here? Absolutely sure? Because I see you committing the same mistakes again and again. That's why I'm asking you again and again. Okay, but then yes, this is the subnet mask that we have. Okay, because it is /18 means first 18 bits are going to be all 1. So the first 2 octates are 16, so that is fine, 255.255. But the third octet which we talk about is going to be the first 2 bits. That's correct. It's in the third octet. The first 2 bits are going to be 1. The remaining 6 bits are going to be 0. So based on that, it's going to be 192. Okay. Now based on that, now if I want to calculate the network address, okay, so again it was the same story. Like since your subnet mask itself went wrong, everything else will go wrong. Okay. So anyways, let's try to calculate the network address now. So to calculate the network address, okay, the first 2 octates are going to remain the same, because if you look at the subnet mask, it is 255, right? So it's going to be 172.38. So that's not a problem. Now let's talk about the third octet. Now the third octet, if I want to calculate about that, okay, if you look at it, we'll have to represent 96. So 96 can be represented in this format. So it would be 0, 1, 1, 0, 0, 0, 0, 0. That is what is 96. Okay, and we are supposed to AND it with 192. So that is going to be 1, 1, 0, 0, 0, 0, 0, 0. Okay, so this is what is 192. Now if you notice, like I'm able to pretty quickly come up with these values. That's because it's all about practice. I mean, the more you practice, the more you would be able to come up with the answers quickly or the values quickly. Okay, but then that's the main thing about it. Okay, so now if you AND these values, okay, now if you notice, only the first 2 bits are ones here in the subnet mask. So naturally only the first 2 bits are going to remain the same. So effectively it's going to be 0, 1, and then everything else or all the remaining 6 bits are going to turn to 0, because you are ANDing it with 0. So bottom line is it's going to be 0, 0, 0, 0, 0, 0. Okay, so this is what you're going to get, which means now the third octet is going to be 64 dot. Now if I look at the fourth octet, it is 0 out here in the subnet mask, which means it's going to be 0. So this is how you would get the network address. Do you understand this? Okay, okay, great. Okay, so based on this now, can you calculate the host address and the broadcast address and give me the values? Okay, now what is this value that you've given me? Are you sure about the host address? The host address is IP address minus the network address. Okay, let me ask you again. Are you still sure that this is the value? This is the host address? Okay, don't panic. I mean, take your time. I don't mind you taking time and coming up, but be sure to give me the right answer. That's what I want. Because the more you try to do it faster, you're going wrong. So slow it down. I don't mind, but take your time and give me the correct response. That's what I want you to do. Okay, so coming back now. Okay, I see that your response is a bit incorrect again. So let's quickly go through that. Okay, now this is my network address. So let's calculate the host address. Okay, now to calculate the host address, the first thing that we need to do is, okay, we need to subtract the network address from the IP address. That's what we need to do. So effectively, it's going to be 0.0. That's the first two octet. Now the third octet is going to be 32, and then the last octet is going to be 254. Okay, so this is what is going to be your host address. Now, one thing that I notice is you're always getting confused with the broadcast address. Okay, so what we need to do here is let us add one particular step here. Okay, you're supposed to calculate how many network bits and how many host bits. Okay, so network bits, according to this example, you'll come across it or you'll get to know about it from the subnet mask. So if you look at the subnet mask, it is /18. So which means the number of network bits that you have is 18, and number of host bits, okay, that you would have would be the remaining, that is 14, because total that you have is 32. So which means number of network bits is 18, number of host bits is going to be 14. Okay, so that is what you would have. So according to that, for broadcast address, what we are supposed to do is the last 14 bits we are supposed to make it all ones. So which means it is going to be something like this, like 172.38. That is going to remain as it is. That's the first two octet. Now for the third octet, okay, since it is /18, the first two bits are going to remain the same. That is 01. That is what is this 64. And then the remaining bits you are supposed to make it all ones. So that is going to be 111111 dot 11111111. Okay, so effectively this value comes out to 172.38.127.255. This is going to be your broadcast. Okay, now I'm sure that this single example is not going to solve the confusion that you have. So what I'm going to do is I'm going to post some more questions in our forum which you can go through and give you the solutions. But meanwhile, we'll stop at this for today and we'll continue in our next session. Okay, so see you in the next session then. Bye.